So we've got a battery of 9 volts here. So we put that before and afterwards. We've got 9 volts, and it's the same over here. This is 9 volts. And if you get, well, as you can see, we've got a little bit of resistance in the wire. But if we put this out, if we measure the current with the 9 volts battery, we have a current of 0.45 amps when we have these two light bulbs. We're assuming all these light bulbs are identical. We can see that these ones in parallel are brighter than the ones in series. We already knew that, because that's not too surprising, because the electrons have to go through two light bulbs, and so they're going to have to share that energy. That's going to come to my next point in a moment. They're going to have to share the energy that they've been given from the battery as they go through one and then through the other one. So the current ends up being 0.45 amps. When you look over here, these ones in parallel, then that's 0.9 amps, because the electrons here are only going through one light bulb. And so they're not going to be slowed down as much as when they went through two. So that one's also 0.9 and that one's also 0.9. Meanwhile, this current up here is actually 2.7, because what's happened is when I added these other light bulbs in parallel, I gave these electrons more opportunities to get around the circuit. And also, because we know that the current's going to be 0.9 amps through each one, because it's going to be twice as much as 0.45 amps, then we have to make sure the supply of electrons are going to be enough to meet that current. So it's going to be 3 times 0.9, presuming the light bulbs are identical, which is 2.7. So 2.7 amps. Now let's go back to the voltage. The voltage is the same through each one, because we know the voltage. So the voltage is always the same in a parallel circuit as it is in the power supply. And the reason for that is because it's the energy per charge, and all the electrons got the same amount of energy per charge as they go through this light bulb, because each electron only ever goes through one light bulb in this parallel circuit. However, if we go through the series circuit, what do we think we're going to notice as we put the voltage across both light bulbs, or across this light bulb and across this light bulb? So let's have a think about that question. So the amount, remember that the battery is telling you the amount of this, the difference in energy per charge, so which is 9 volts or 9 joules per coulomb. And it uses all that energy up as it goes through these two light bulbs, apart from a little bit because it needs to get through the wire. Now, because some of it gets used up in the first and some of it gets used up in the second, the voltage across just the first one is 4.5, negative 4.5, because it's actually losing energy rather than gaining. And then as you go through the second one, it's also going to be negative 4.5. I've switched the electrodes around, but anyway, 4.5. And so it's only when you go through both of them, it actually ends up being 9. So yes, the light bulbs are using up the energy and the batteries are giving it the energy, but apart from the sign, as in positive or negative, the value will be the same if we ignore the resistance in the wires. Whereas in the parallel circuit, it's the same as the power supply, because all the electrons are going through just one of them. Okay, right.